Hi, my name is Anjeli Flores, and in this video I'm here to inform you on identifying plastics. Today's world has become dependent on plastic, but as much as it is convenient for us humans, the same can't be said for our planet. It's simultaneously developing and harming our home, in which we call Earth. We produce 300 million tons of it every single year, most of which will end up in oceans, landfills, and essentially anywhere it can exist, and where we deem it most convenient for us to simply put to the side and call it a day. We don't see its bigger impact as it accumulates. We have our trash taken away on Thursdays for our bins to reset and start another week doing exactly what we did the last. But the landfills that our garbage is taken to can't do the same. They can't reset. Point is, we should be more conscious of our impact on our world no matter how little. I want to talk about plastic. The Plastic Resin Identification Codes, RIC. RIC. So what initial knowledge do we have? Do you know what plastic resin identification codes are?
Oh, it's the oh, I know what you mean now.
Mm-hmm.
It's like the symbol, right?
Yeah.
Yeah.
I have no idea. I know nothing about them yet. Establish a difference between different kinds of plastics. Lots of other plastic bottles probably have them on the bottoms.
No. The amount of bottles they're producing in the company and how much they need to recycle. Plastic bottles, containers.
If it has BPA in a plastic, or how it can be recycled, and if my local recycling center can take in that plastic and recycle that plastic.
Take the plastic bottles to the plastic depot place so that they can identify the bottles so that they can make new ones.
Plastic resin codes, they sound like they'd be used for just to code things, label things, like plastic goods and merchandising. I don't know, like bags, stuff like that.
It's like a very polluted area of trash. Figure out what is being used and placed. Next question.
For a lot of people, these symbols are just there. People know that they exist, but not really what it's for or what they're called. So, in this video, we will talk about what those chasing arrows are all about. Plastic resin identification codes were made to categorize types of plastic to provide recyclers and manufacturers worldwide with a consistent coding system. Developed by the Society of Plastics Industry, SPI, and the American Society for Testing Materials about 30 years ago, in 1988, had initially intended for assisting waste recovery facilities to organize plastic quality before recycling. Even though you may find the chasing arrow symbols that are associated with recycling on the logos of these codes, some of these types are not safe for recycling. Reuse, repurposed, reusable, all that, but are dangerous to the environment. The 4 types you see on screen are dangerous to dispose of, so try to avoid consuming these if you can. 3 of these types have one certain thing in common. They're thermoplastics, which we will get into later. All plastics are made up of polymers, which are long, flexible chains of chemical compounds. Molecules that repeat. This structure allows for plastic to be easily flexible, sculpted, and molded under heat and pressure. The RIC that we use and see every day, even if we may not know what it is, has become vital to recyclers, consumers, and essentially everybody managing plastic materials. There are 7 plastic codes. Number 1, PETE, polyethylene terephthalate. Number 2, high density polyethylene, HDPE. Type 3, PVC, polyvinyl chloride. Type 4, LDPE, low density polyethylene. Type 5, PP, polypropylene. Type 6, PS, polystyrene. And finally, type 7, other, which includes silicone and polycarbonate. Now that we have an idea on what the RIC is, let's start off with type 1, PETE or PET, which is polyethylene terephthalate or polyester. One of the most commonly used out of all 7 types, it can be found in drink bottles and containers, 3D printing and more examples on screen. PET is made up of ethylene glycol, which is a chemical chain naturally occurring hydrocarbon gas through combustion, and terephthalic acids, which is combined to create a polymer chain. These strands of PET can be cut into tiny flakes and into newly processed material that can sculpt the plastic into any shape or form. This process is applicable for plastics in general. We use these single-use products every day of our lives, such as our beverage containers, disposable packaging, and the list goes on and on. This plastic is recyclable but not biodegradable. PETE, a lightweight plastic that is very recyclable. Up next is Type 2, HDPE, high density polyethylene, one of the most widely used materials. From the jugs that can hold a gallon of cow's milk to fuel in car tanks, this type is very versatile. Some qualities include it being impact, weather, mold, and rot resistant, and also long lasting. From outdoor patio furniture to hair product containers, being so versatile, these combined qualities make it an ideal material for almost anything, really. It does not contain BPA, phthalates, heavy metals, or harmful fumes. Even better, HDPE is good for replacing bulkier and less convenient mediums, making it an alternative for pursuing sustainability goals for many companies whilst keeping the quality of products the same as it was before the switch, and maybe even better. Type 2 is non-biodegradable, taking centuries to decompose and break down, so it is crucial that this type can be reused, recycled in some way. Type 3, PVC, polyvinyl chloride, one of the more softer and flexible plastics. It is naturally white and brittle. Being one of the more older synthesized plastics as of 1872, it has been used and trusted in industries such as construction and healthcare leading up to the 1950s, where all plastics were available to the public and from then on grew in popularity. It makes up products from plumbing to medical devices to shoes and clothing. It can be found in packaging and food foils. PVC is a thermoplastic, which means that it is capable of remolding and reshaping. It is high impact and chemical resistant, a strong and aesthetic whether crystalline or rubbery plastic. There is also another classification of plastic called thermosets. As opposed to the other type, they remain solid once they have hardened. PVC is, although a human health and environmental threat. Both its disposal and production involves dangerous chemicals that, if consumed and come in contact to in small amounts, can cause reproductive impairment, birth defects, and even brain damage if its chemical is leached. This is because they involve phthalates, which imitate human hormones and cause abnormal development. Burning and essentially any form of disposing of PVC should be avoided as it releases dangerous chemicals such as lead and cadmium. Although some products can be repurposed, overall PVC is not safe for recycling. For the meantime, it's best to put this in the garbage. Alright, type 4 LDPE, low density polyethylene. First of all, what's the difference between HDPE and LDPE? Well, it's exactly what it says. LDPE has lower density than HDPE because of its molecule structure being branched out rather than in organized rows that HDPE has. They have similar uses but possess different qualities. Type 4 can be found in your crushed bottles, shopping bags, and most lightweight packaging. Although it is lightweight, low-density polyethylene is strong. It doesn't break easily, is resistant to water, resistant to hazardous chemicals, and can be easily processed. It is easily processed at low costs. It is most popular in packaging. The biggest market for LDPE is packaging, and according to ICIS.com's market data on polyethylene, making up for around 50% of the world's consumption of plastic. But is it recyclable? If your LDPE materials are clean and dry, they can be collected and brought into more than 18,000 retailers worldwide, which, if you think about it, isn't that much. We really could do better. But from the liners of cereal, of grocery bags, and bubble wrap, they can be given another chance to be recycled into other products, remade into floor tiling, furniture, lumber, timber, and the list goes on. Type 5, PP, polypropylene. Said to be one of the most lightest and versatile polymers, like Type 3, it is a thermoplastic. It is lightweight, has excellent resistance to chemicals and fatigue. It also has a high resistance to electricity, which makes it good for insulation for electrical components. This plastic is still not as flexible as the other types though. You can find polypropylene holding your ice caps and also in your furniture, pipeline insulation, and car exteriors. And yes, polypropylene is safe for recycling and reuse. Type 6, PS, polystyrene, a thermoplastic. Polystyrene, also known as styrofoam, is inexpensive, lightweight, and is easily produced, and is versatile, making it popular for single-use products. These products consist of styrofoam cups, plastic cutlery, styrofoam packaging, and so on, but aside from everyday use, it is also used in the construction industry, valued for insulation and cushioning. Polystyrene has weak structure and is extremely lightweight, and packing peanuts, styrofoam, which are 95% air, make it easier for it, as it already can, break up. After breaking up, it spreads wherever it can throughout our earth, washing up on beaches all over, polluting them. The amount of sea creatures that have been affected by this has not been released, but an undisclosed number has consumed this plastic and have suffered due to it. What about our very own landfills? According to ecomana.org, styrofoam makes up for less than 1% of the collective weight of landfills. Take in, this plastic is extremely light. Also take in that it cannot biodegrade, unless thousands of years in landfills sounds worth it. And because it is so light, it can be lugged by wind so easily, it can be carried all the way to oceans or back onto the streets. On the upside though, scientists are working towards creating biodegradable polystyrene. But on our part, reducing the usage of this plastic can really help our environment. And finally, Type 7, Other, can be found in compact disc productions such as polycarbonate, and the list goes on as long as it doesn't fall under the rest of the other 6 categories. This section consists of every other plastic but the initial 6. There aren't many specifics on this one as it covers a wide range of materials, so I'd say avoid this because of uncertainty. One of the main concerns that we have with Type 7, the other category, is chemical leaching into foods. Products may market as non-leaching but could still contain BPA, bisphenol A. Bisphenol A may find its way to your beverages and food. We're concerned with this because it has tied in with cases regarding our brain, behavior, cancer, heart problems, and increased risk on underdeveloped bodies such as children, and also many other conditions such as obesity, diabetes, ADHD, etc. But that's just one concern. Be sure to take precaution before consuming Type 7. Thanks for making it to the end of Chasing Arrows. There's definitely a lot more to this topic than what I've covered in this video. But now that we have basic knowledge of what these chasing arrows are, we can return to our daily lives, hopefully a little more conscious and curious as to what our world is made up of.